So, in the previous class we were discussing with the milk fat, right. So, in this class of dairy and food process and products technology, so on the lecture number 21, sorry, in the lecture number 21, we are coming to this the milk fat, right. So, we said milk fat is the esters of fatty acids of alcohol or glycerol. Typically, it is esters of fatty acids of glycerol, right. It can be mono, di or tri. Now, then it comes obviously what is fatty acids, right. So, fatty acid is a long chain carboxylic acid, right. General formula it can be CH3, CH2 whole N, COOH. Obviously, carboxylic acid is COOH, right. So, it has I do not know whether you still know it or that carbon has 4 hands like that, means 4 valency, right. So, it can combine with 4, out of which CH3 3 are taken out. So, 1 remains, right, or COOH, in there also C double O and OH. Hopefully, we know that how COOH is written, right. So, this is C, this is double one O and this is one hand free and this is H, right. This is OH, sorry, this is OH, right, this is OH. So, if we C O or above O double bond and free and this is OH, right. So, if that be true, then this hand becomes free, right. This is what the valency that becomes free. So, this if we substitute with one hydrogen, that is HC double bond OOH. Now, this also can react because this is also an acid, this also can react with the glycerol, right. But normally formic acid is one which up to 1, 2 or 3 carbons, normally it is not said to be fatty acid. It is the chain means CH3, CH2 whole N COOH. If we make N is equals to 1, then it becomes CH3, CH2 COOH, which is nothing but if had it been CH3 COOH from formic acid, then it is acetic acid, then it is propionic acid, right. So, CH3 CH2 COOH would have been propionic acid, but normally up to 3 it is avoided. Normally it is because that is the natural occurrence. From the nature, the occurrence of the fatty acids is seen to be from more or predominant from 4 C4, right. But C4 constitutes of all, right. Let me clear it up. C4 means your here CH3, CH2, CH2, COOH, right. This goes off, or is the eraser, highlight, eraser. So, this goes off, right. This goes off, it is CH3, CH2 like that. So, in that case, this is the butyric acid, right. Subsequently, you will see in our class or in books also, you will see this COOH, though there is a carbon, this carbon and along with that acidic group, carboxylic acidic group, they are taken aside. Normally, the number of carbons they are said in terms of this, that is how many carbons are there, CH3, CH2, CH2, that is 3 carbon, C3, right, because COH is common to all carboxylic acid. So, C3, C5, C7, C9, C11, these are all odd numbers of carbon chain, and C4, C8, 6, C8, C10, C12, C16, C18, they are all even number of carbon chain, right, and because carboxylic acid is common to everybody, right. So, that is why though the general formula is CH3 CH2 whole n COOH, and in that if n becomes 1, then it would have been propionic acid, but occurrence of the tri or mono or di, whatever the glyceride, occurrence of the ester of glycerol with the propionic acid or acetic acid or formic acid is very negligible or not there, right. So, that is why they are said not to be the fatty acid, right. So, fatty acid, then we tell carboxylic acid with carbon chain where the chain length is minimum 4 with the carbon, without carbon it could be 3. So, normally these 3 onwards we take, there could be, normally it is said C2 and onwards, because officially you see if we put n is equals to 1, then it becomes CH3 CH2 COOH. So, it is 2 other than carboxylic acid. So, 2 to 80 it can be, but that is maybe 1 in C80 or C70, maybe in 1 in thousands or lakhs of sources you may get. So, that cannot be taken as, but commonly mostly it is between C4 to C20, within this range most of the fatty acids they are in nature. So, we call accordingly C4 to C20, right. So, many varieties are available in nature, even numbered fatty acids are more in nature than those for odd numbers ones. Now, even numbered and odd number, as we have said, this is do not make the confusion, because subsequently you will see that it depends on the books how they are following. The writer, I am talking about the basic books, I am not talking about the books which are, I do not say copied, but at least which are edited, or lot of writers are there. If it is a single author book, normally we take that to be more prominent, more informative, etc., or reliable. So, in that case, if you look at books like, as we said, Fenema, Desrochier or Mayer, these are some of the food chemistry or this oriented or technology oriented books are there. So, if you look at them, some books may also follow that the even number is with the fatty acid. Some books may say, no, since fatty acid is always there in the that acidic group is always there. So, if we remove that and tell about the chain length in terms of number of carbon atoms, then it becomes more convenient. So, that is why even or odd, that is subjective. So, if we are considering the carboxylic group also as one of the member, then even numbers are more prominent or more available in nature than the odd numbers, but in the reverse, if keeping aside the carboxylic acid group, then we say that odd numbers are more available in nature than the even numbers, right. So, you do not make it confusion, this is absolutely clear that even number with carboxylic acid group, then it is a more occurrence in nature, but odd number without carboxylic group, leaving aside the carboxylic group, carboxylic acid group, that if that be there, then that is more occurrence, it occurs more with the even odd number, right. So, if we leave the carboxylic acid group. So, even or odd, that is subjective. So, until and unless you specify, do not get confused, right. So, even numbered fatty acids are more in nature than those for odd numbered ones. Then comes saturated fatty acids, right. Now, out of these fatty acids, now like this one which we have shown, let me erase it. This one, now if suppose we have carbon like this, carbon like this, carbon like this, go on, right, C, C, O, O, H, this is the carboxylate group, right. Now, if whether all of them are with hydrogen, so then it becomes alkyl, right. If all of them with hydrogen, then it becomes a alkyl group, whatever be the name. So, if out of that one is replaced, if out of that, no, not that, this one. See, out of that, if one is replaced with a double bond, right, then it becomes unsaturated, because unsaturated means there has to be a double bond. So, if there is a single unsaturation, then single double bond. If there are multi unsaturation, then there are multi double bonds available. But if the double bond is not there, as in the earlier case we have shown that all the valencies are occupied by the hydrogen, then or may not be all the time hydrogen, maybe if they are grouped, right, iso, that also can be. So, depending on how they are attached, but if they are all with some or other kind of valency with hydrogen or equivalent substitution, then they are saturated, right. So, then we call it to be saturated carboxylic acid. Now, this saturated carboxylic acid, when it reacts with the alcohol, that is glycerol, then the esters which are formed may be again saturated mono or di or triglyceride, depending on how the how many number of alcohol groups are esterified, right. So, between C2 fatty acids containing from 2 to 80 carbon atoms per molecules are known. In most animal and vegetable fats, C2 to C20, particularly C16 and C18 are found. Saturated fatty acids with more than 24 carbon atoms are not commonly encountered or is not available, right. Seldom occur in food triglyceride. Beyond, that is what I was saying, that though theoretically it can be that C2 to C80, right, theoretically it can be, but for all practical purpose, those which are available in nature, in out of that it is mostly seen that between 2 to 20 it is varying, and that too it is also said that C16, C18s are more occurrent in nature, that is their availability in nature is much more. But beyond C24, it is seldomly occurring in nature. Artificially you can do anything, that is altogether different. Artificially you can produce anything, right. Now, artificially people are polymerizing those polymers and that polymerization you can do as much you can polymerize. depending on that different products are coming up. Every now and then some or other kind of polymers are coming in the market, but they are all man-made, they are not natural. So, natural these polymers or rather poly chain, right, chain of these carbons in the fatty acids, they are between 2 to 20, and out of that 16 and 18s are more occurrent than any other, and beyond 24 they are seldomly seen, right, but do so in waxes. Yes, if it is more than that, instead of fatty acids, instead of esters of glycerol or glycerides, it forms wax, right. Wax is also kind of this comes under the lipid family, right. This also comes under the lipid family, but there the number of carbon atoms are more than 24 and they are high chain, long chain carbon atoms, and they form waxes. Between C4 to C10 they occur mainly in milk fat such as butyric acid. Here as you see we are giving here that CH3CH2 CH2 CH3CH2 COH, that is 1, 3, 4, including the carboxylic acid, it is 4 butyric acid, right. Again I say the subsequently at some point you may say that without the carboxylic acid this number will be C3, right. So, again and again this confusion do not keep, you have to be very specific. That is why explicitly I have given the formula for butyric acid with C4, right. But if I say that butyric acid is C3, then you have to keep in mind that COOH is omitted, right. This is excluded, excluding that COOH, butyric acid is C3, right. In that case it becomes odd number, right, though it corresponds to butyric acid, which is including the carboxylic acid is the even number, right. So, do not make confusion, you have to be specific, and the moment you are specific you can write like this, that yes, butyric acid is this. Similarly, some other acids like capric acid, that is CH3CH2 whole 4 COOH, that is 4 and 1 5, and then COOH, that is 6, it was 4 C4, it is C6, caprylic, that is CH3CH2 whole 6 COOH, then capric, that is CH3CH2 whole 8 COOH, right. So, all these are occurrent in milk, all these are fatty acids occurrent in milk between C4 to C10. Between C12 to C24 are found mostly in most vegetable and animal fats. So, milk contains mostly between smaller chain, that is 4 to 10, 12 onwards up to 24, it can be available mainly in some plant origin vegetables or maybe some animal origin fats. So, depending on that whether it is plant origin or animal origin, depending on that this number also may vary. Will also come sometime maybe lard, that is one which is a animal fat, and the price of animal fat is much lower than that of the either milk or vegetable fat, right, much lower, and the quality is also much lower. Quality in the sense the assimilability in the body and the consumer is much lower. That is why their price is also very low. You can easily see if you go to any slaughterhouse, right, lot of animal fats are there, right, and those animal fats either being thrown away or people buy with very limited money, a very small amount of money they buy. The one of the reasons that is not true, even if you go and if you do not need to separate fat, just the whole milk if you buy is much higher, right. Though you are getting along with milk fat, you are getting protein and carbohydrates and many others, but if it is separated, then the price will go even higher, much more higher, right. So, that is why the fats are in milk, it is small chain carbon between C4 to C10, C12 onwards is normally available in vegetable fats or animal fats. Fatty acids with odd number carbon atoms are found in animal and vegetable, in animal and vegetables in odd numbers. That odd number includes this COH, right. This COH is included, but they seldom exceed between more than 1 to 2% of the total fat, right. The total fat which is present, out of that these odd numbers are only around 1 to 2%. It is mainly the even, and this even one is including the carboxylic acid group, and the odd one is also including the carboxylic acid group. So, the odd numbers are rarely found, is small in quantity, less in quantity, and percentage wise, as we said, it is around 1 to 2% and mostly occurrent in the higher, of course, higher carbon chain C12 to C24, that is available in plant origin and animal origin fats, right. The common saturated acids are lauric acid, which is CH3 CH2 whole 10 COH, myristic acid, that is CH3 CH2 whole 12 COH, palmitic acid, that is CH3 CH2 whole 14 COH, stearic acid CH3 CH2 whole 16 COH, right. So, these are common saturated acids which are there. Now, out of that, let me see, yeah. So, perhaps one blank came. So, out of that we saw that up to 16 we have said, that is palmitic, stearic acid, right. And there are unsaturated fatty acids also, and these unsaturated fatty acids, they do have double bonds, and depending on whether it is a single unsaturation or multiple of unsaturation or multiple unsaturations, depending on that they are also named differently. Like you might have heard that there is a term called PUFA, that is polyunsaturated fatty acid. You will see in many advertisements of fats and oils, they do claim that it is having very unsaturated fatty acids. And by the way, that many these unsaturated fatty acids are not normally synthesized by our body. Our body are not able to synthesize, that is why from the external sources they are being supplied. That is why in the advertisement it is being highlighted that this contains polyunsaturated fatty acids, and this is much more better for your body, that is what it being claimed. So, what is that? unsaturated fatty acids that both number of carbon atoms and double bonds characterizes this, right. Though there the double bond may vary between 1 to 6, right. Usually 1 is there, but it can be more than 1 up to maximum 6 are naturally occurring unsaturated fatty acids available. In that, some of the names are like this: myristic acid, or it is myristolic acid. Myristolic acid is CH3, CH2. Myristolic acid is CH3, CH2, CH3, CH3, CH2, O3, CH double bond CH, CH2, O7, COOH, right. So, from the left, from the carboxylic acid group side, it is C8, where the between C8 and C9 the double bond is, right. This is number 1, and from there 7, 8 and this is 9. So, 9 and 10, sorry, this is 7, 8, 9 and 10, between that it is myristolic acid. Similarly, in palmitic acid, it is CH3 CH2 whole 5, CH double bond CH, CH2 whole 7, COOH. Then oleic acid, it is CH3 CH2 whole 7, CH double bond CH, CH2 whole 7, COOH. Here you see that number of double carbon atom where double bond is 1, 8, 9, again here also between 9 and 10, here also between 9 and 10, right. But this side the numbers are different. Here it was CH2 whole 3, here it is CH2 whole 5, here it is CH2 whole 7, right. But this side all of them have the same configuration, right. Then from oleic acid, if we go, it is linoleic acid, where it is CH3 CH2 whole 4, CH double bond CH, CH2 CH double bond CH, CH2 whole 7, COOH. Again 8, 9, between 9 and 10 position 1, and then 11, 12, between 12 and 13 position another. So, 2 double bonds in linoleic acid, right. In linoleic acid 2 double bonds are there. So, the more the double bonds are there in unsaturated fatty acids, better it is, because it acts if the external, if oxidation is there, then oxygen can easily combine in this double bond. So, this can be taken by one oxygen or another oxygen, or may not be oxygen, but some other substituted product that can come up, right. So, there we can see that between C9 and C10 one double bond, and between 11, 12, between 12 and 13 one double bond in linoleic acid, right. Similarly, in linolenic acid, it is CH3, CH2, CH double bond CH whole 3, then CH2 whole 7, COOH. So, one methyl group outside, and then CH2 CH double bond CH whole 3. So, there are 3 such groups, CH2 CH double bond CH, 3 unsaturation is there in linoleic acid, right. So, 3 unsaturation in linoleic acid, and there it is CH2 CH double bond CH whole 3 is associated with one side with methyl group, and the other side with rest of the earlier that 8 C8 or 9. COH, then CH2 whole 7 and then CH double bond, right. So, that 1, 7, 8 and 1, 9. So, 9 position those things are same like this, right, like this one, right. Here it is COH, CH2 whole 7 and then it is the double bond which is coming here at, right. And this like this is the 3. So, this is 3 double bonds. Here we have 2 double bonds and in all other cases this is single double bond. Then a typical another one called arachidonic acid. Arachidonic acid is CH3, CH2 whole 3, CH2, CH double bond CH whole 4 and CH2 whole 3 COOH, right. This is we call where we have 4 double bonds. So, we have given, we said between 1 to 6 double bonds are there naturally occurring unsaturated carboxylic acid. So, we have given example up to 4. If we would have given 5 and 6, it would have been much more complex. But it shows that the higher the number of carbon atoms, there is a possibility of unsaturation more in that. Lower number of carbon atoms like C4, C6, C8, C12, C10, there these unsaturation possibilities are less, because you have to have stereochemically stable. The compound also has to be stereochemically stable. Stereo means in the special arrangement that compound has to be stable, right. So, in this another information I would like to share in this class, that oleic acid which is available, oleic acid is this, right. Oleic acid which is available in olive oil. In olive oil around 75% it is oleic acid, around 60 to 80% linoleic acid is in safflower seed oil. Safflower seed oil contains around 60 to 80% linoleic acid, which is also having a single double bond, and around 75% is the oleic acid present in olive oil. And you will see nowadays people have also started using olive oil as one of the oil, cooking oil for themselves. Many people who can afford, of course, olive oil is a costly oil, much costlier than normal available oil or vegetable oils. But vegetable oils also are nowadays, the prices are going up, and we see here that linoleic acid is around 60 to 70 or 80% available in some of the vegetable oil like safflower seed oil, right. So, like this we need to know some of the chemistry, otherwise it is not possible to follow why and how and when, etc. All these W's are to be answered, right. Okay, we will continue this part in the next class also. Thank you.